Hello, hello everyone.
Hello. Hi.
All right. So thank you for joining this meeting. And without wasting so much time, we're gonna get started so that we can we can cover a lot. So I want to introduce myself. My full name is Miracle Chibuza Marcel, and I am the coordinator of the Pan African Asteroid Search. In our program, we train people on how to search for asteroids orbiting the sun. You know, like the last meeting that we held, I tried to explain the reason why we search for asteroids. First of all, I explained why we have lots of asteroids in space. 5.5 billion years ago, the the solar system was formed. And just like after building a house, you can just have some leftovers. So the leftovers could not form a planetary body, so they were in pieces. So they formed the asteroids, and majorly located at the main belt. Main belt is between the orbit of Mars and Jupiter. So now, these asteroids are quite stable on their own, but because of the presence of Jupiter and Mars, they get distorted. Their orbits get distorted, and they change. And sometimes they can come in the way of the Earth, and that is when we have this collision. So, since the formation of Earth, we have had about five of these collisions or more. And anytime they collide with Earth, they cause a lot of damage. The latest one that we had was in 2013, when an unidentified asteroid struck Earth. It damaged lots of property in Russia. That was in Russia in 2013. So after that particular event, the international community, you know, started to rally around on how to track these dangerous asteroids. So that is why we have many surveys set up around the world to monitor them. And when they collect the data, we have so much data collected, they cannot exhaust the data. So they call upon the collaboration of ordinary people to come in to analyze, to come in to help in analyzing these asteroids. So that is why we are reaching out. So this program has been on since 2005, but it became more serious after that 2013 event. So, but since then, we haven't had Africans participate much in the program. So that is why I took it upon myself to spread across Africa, because I know lots of Africans love space, and this is a good program that can help them to enhance their knowledge about space, and also to contribute into their research skills. So that is why we are having this program. So last time I showed you some things to download from the Isaac website. Let me share my screen so that you can see exactly what I am doing. Let me share my screen so that you can see exactly what I'm doing. So I want you to respond. Can you see my screen?
Yeah.
Yes.
Yes, we can.
Okay. All right. So last time I said you should download these two two programs. Like this is for the astrometrical software. This is the software that we use in the analysis of the data, and this is the practice image. This is exactly the kind of data that we use, but this is old, so we use it for practice. So Isaac people input it there so that before you can start a proper campaign, you must have learned how to search for asteroids with it. Then this is the guide. You can read up after the training. You can just read it up so that everything that we will treat today will sink in properly. So, but you can just ignore that for now. So, but I hope you've all downloaded this tooling because I want to start from here. So, if I go to my downloads, so this is I've downloaded the practice image sets into my system. So, and if you observe, this is a kind of file that we call compressed file or a zip file. So we have to unzip it. We have a special program from zipping it called WinRAR. I hope you have it in your computer or any maybe an inbuilt window program for opening it. I hope you have WinRAR in your system, or I should go to where you can you can download it. I want to confirm if all of you have WinRAR in your computer.
Yeah, I do.
Okay, so I want to open it. Okay, sorry for. Okay, how to extract the files. I mean, so extract the files. So you can extract yours if you haven't extracted it. Extract it if you haven't extracted it. So I have extracted it and I have this. So you have about 5 of these practice image sets. And for the purpose of tonight, I'm going to be working with 2 so that afterwards you can work with the other 3 to practice further. So if you have installed the Astrometrica program, I want you to open it. Go to your desktop and open it. This is for my own here, Astrometrica. And you have to open it from the desktop. Do not open it from the folder because some people make that mistake in opening it from the folder. So open it from the desktop. So the first thing you will see is this black window. It will come up with some things loading on it. This is the minor planet center data loading. So it takes some time depending on the speed of your internet. If your internet is fast, it will it will load fast, and if your internet is slow, it will take some time. But this is just the minor planet center database loading into your system. So this must come out for your system and afterwards a white window will pop out. If this part does not pop out, if this part does not pop out, you're going to have some errors while submitting your report. So you have to make sure that this thing loads. So exactly the same so that you can be following me step by step. If you have issues, maybe if you think I'm too fast, you can just call my attention so I can re-explain what I've explained before. Okay, mine has finished loading because I believe my internet is fast. But how about your side? Any any progress? Hello?
I think for me it's
Can,
done.
can we start over? Cause I was not following.
Okay, I just started now, but let me just start over. Okay, I said that you have to download the astrometrical setup. It is a software that we use for analyzing images, and you should also download the practice images because these are the ones that we are going to be using for the practice. It is exactly as the real data. Do you understand? But the only difference is that this is old. We're going to see the time it was taken, the time this image was taken. We're going to see that. I'm going to show you. But the one that we make use of are they are freshly gotten from the telescope. Okay, freshly. So when you start your campaign, that is when you will have them. But for now, we're going to making use of these practice image sets. So last time we had this meeting, I said that you should download them. So once you download them, make sure you install this one. Make sure you install it. It is very easy to install. Okay, and it is going to when you install it, it is going to ask you for a key. So if it asks you for a key, use this key. Use this key. It's coming. Can you see my screen clearly? This is the license key, and this is the password of the key. But even if you fail to enter the key, it can allow you, Isaac will allow you to use it for 100 days. That is about 3 months plus. Afterwards, it will expire. But if you input the key, you can continue to use it on and on. So if you haven't, uh, after installing it and after loading, if you haven't input the key, you have to do that. Do that. So look at what I have. I want to know how many of you are at this stage.
I am not sure about everybody else.
Okay. I want to know the progress of everybody.
I'm still extracting the file from the.
Okay.
I'm still busy downloading.
Oh. Okay. Um. Okay. Just hurry up so that we can wait for you.
When we're opening it, should we open it via the folder or
No, from the desktop. From the desktop.
okay?
If you open it via the folder, you're gonna have errors. Why numbering your data? So open from the desktop. You know, lots of people make that mistake, and I correct them. So you open it from the desktop, from the icon on the desktop. So this is what I have here. They said replace existing file. Say yes. So I think we should just give those that are still lagging behind 5 minutes to meet up. 5 minutes to meet up. So So I want to extract this first one because I want us to work on the first one, the first practice image. Okay, look at it. Look at it closely. You will see practice PS1. This is PS means Pan Star because these images were taken from the Pan Star telescope. So we have Pan Star Telescope 1 and Pan Star Telescope 2. Over the years until 2021, 2022, sorry, over the years until 2022, Isaac um, have been has been given data from the Pan Star 1 telescope. So from from 2022 till now, they upgraded their telescope to PS2. So when you start your campaign, you're going to be seeing PS2. But for the practice, we have PS1. That is Penstar 1 telescope. Then we have 2019. You see that this is for the year. This is the year this was taken. This is the month 2019 8 the 80th month, and this is the on the 28th day. So let's open it. I want to analyze this first one first. So I'm going to extract it. So I want you to do the same as we wait for others to come up. All right. I don't know if you're still if you have come up to our level. For those that are still behind, or should we move on? Should we move on?
Yes.
Okay.
Okay, yes.
Okay.
Yeah, we can move on.
All right. So let me expand this window. This is the astrometrical window. And if you look here, you will see some buttons here. I'm going to teach you what these buttons are used for. Then we have this file, this other menu bar. But most importantly, I want you to look here where my mouse is going. We have PS1 CFG, PS1 CFG. What do you have in your own? What is there in yours? If you have opened the software.
Mine says the same thing. It also says PS1 CFG.
Okay, good, good. How about others?
Same here.
Okay, this is the configuration file. You know, I just showed you the the files that we're going to be analyzing. I showed you the files, and this is PS1. So it means that if you want to analyze PS1 images, you have to check if your configuration file is on PS1. But if you are analyzing PS2 images, you have to change this to PS2. Okay, let me welcome this person. So if you are analyzing PS2 images, like when you start your campaign, you need to configure this to PS2. And how do you change that? How you change that is by going to the file here, click on the file, and go to settings. So when you go to settings, you go to open, and you will see so many configuration files. But the one that concerns us are just these two, PS1 and PS2. So if you are working on PS2, you have to click on this and say open, then okay. And if you check now, it is now PS2. But if you are working on PS1 images, you go to that same place and click on PS1. So I'm going to leave it at PS1 because we are working on PS1. So, but I have shown you how to change the configuration file. If you make the mistake of analyzing a PS2 image with a PS1 configuration file, you're going to have error while submitting it. So that is why it is important that you check the configuration file that you are using before you load the images. You have to check it before you load the images. I mean, why the images that we're talking about here are fit files. Do you understand? So let us even explore it. Let's explore it further. If you open this, you will see about four files. About four files. These are the images of that patch of sky that that were surveyed. So there was maybe some intervals of time, like 1 hour or 2 hours intervals of time. So what the astrometrical software will help us do is to bundle these images and simulate them. Do you understand? Just like if you take an image of something at a different time intervals and maybe use a software to bundle them and simulate them, it will give you a sense of motion. Just like what you can see on the Isaac website. Let me just show you that. This is the Isaac website. You can see this image moving. These are about 6 images, different images taken at different time intervals. So the astrometrical program simulates them so that anything that is moving in that image will appear like this. But for those that are stationary with time, will never move, just like these ones you have here. These are stars in the background. So this is what the program helps us to do. So, but you can't, these are fit files. Look at, these are fit files. But it is not appearing as, it is not written fit. But if you look into your own, it will written fit. The reason is because I have this program in my computer called Games. It helps to open, if you want to process uh, a fit files, it can help you to process it because I'm also into astrophotography. I use it to process images. So that is why you say GIMP. But in yours, you will find you see that fit files. So let me accept this person. Let me accept this person. I hope those people can join us. Oh, I hope they can follow. For those just joining us now. Okay, for those joining us, we have not really gone far. We are just here. I opened the astrometrical software. So maybe since maybe you have downloaded it and installed it, you can just open it so that you can follow up in what we are doing. Hello, for those coming in, can you say hello? For those joining us, can you say hello? Say hello.
Hello.
Okay. So
Hello.
yeah, great.
Hi.
Yeah, I want to know where you are so that we can pick you up from there. Have you installed the program before now? Have you installed it?
Uh,
Have you installed it? Oh,
yes, I've installed the program.
okay. Okay, good. So open it. Open it. Open it from the Windows. Open it from the Windows. So let me walk you through the buttons. This is the settings button. This is the settings button, and you can also access it from here. Settings. So it relates to some settings you want to perform on the astrometrical program. Okay, example, if you want to change the configuration file. And this one is load images. Don't worry about this other two because we may not be needing them. But this one, I want to point out to important buttons that we use here. So this one is, you use it to load images. So now we have opened, we have unzipped the fit files. We can load images from there. Do you understand? Then another important button is this one called the astrometrical data reduction. It is used to extract the images. It is used to extract images. They're going to see how it works. And we have this one is not important, but this one is where to see your MPC report. After numbering your object, this is where to see your report that you will submit to the Minor Planet Center via the Isaac website. Then after analyzing an image, you can close all of them from here, close all images. Then we have this one called uh, invert image. Invert image. You're going to see how we use it. It is one of the most important buttons here. In fact, let's start the work so that you can see the functions of these buttons as we proceed. So I'm going to load the images and I want you to do the same. So I'll come here and I'll click on load images. So I have this window come out. You have to locate where you stored the practice image that you downloaded. So let me just locate it from my PC. I think it's in my downloads. It's in my downloads for me. So you have to know where you kept it. So this is the practice image set folder. And this is the one I opened, but let me see all of them, all files. So these are all the files, but I've opened this one. So I want to load it. I click on it, then I open. Then I open again, and I have those 4 files that we saw before. Sorry, 4 files, yes, that we saw before. So next, you have to highlight all of them at once. You have to highlight all of them at once, and you click on open. Images will open. It will just open to the Automatica like this. So these are the four files. Look at how they look. So I want you to do the same, please, before I proceed from here. Before I proceed, I want you to also give me the affirmation.
Okay.
Okay, everyone, can I proceed?
Yes, we're through.
Okay, so
Yeah.
great. So now look at, Initially, this was not activated. It was just like gray color. But now I have loaded images. It has now activated. You understand? So the next thing I'm going to do is to do astrometric data reduction. So let me click on that. I will click on it. Then I'll have this little window pop out. This is exactly the right ascension and the declination, and even the the patch of the sky this was taken. It was taken from the South Pole. Okay, and if you want to see all the known unknown objects like the stars, uh, even minor planet bodies that were present at that patch of the sky when this object was being taken, you can check them here. If you click on that button, you can even see the objects that were present at the time this image was taken. About 10,000 of them, many, many of them. But you shouldn't just, don't click on OK, and it will begin to load. So I want you to do the same because it takes some little bit of time depending on your internet speed and your system speed too. And if you have any question, please do not hesitate to ask me. I'll be kind enough to answer all of them. So I have this error reference star match error. Is a normal error that we usually encounter while working on asteroid data. It means that the software cannot manually match the reference stars. We have reference stars, the stars that were in the patch of the sky where maybe this asteroid passes, seems to pass through. So it cannot manually match those reference stars. So what you have to do is to click on automatic, come here and click on automatic. So you click on OK. Click on automatic and click on OK. It will just do it automatically. So I want you to do the same. When you do that, you see this little table. So the table is just showing you details of the data for those 4 image data, or sorry, image frames. This for the first one, this for the second one. And you can see this is the reference stars, even the coordinates. We don't need that for now. You can just close it. We don't need that because it is going to be blocking our space. So just close it. We don't need that. So the next thing you're going to click on is known image overlay. Known object overlay, sorry. Known object overlay. So this is about, it is going to give us asteroids that have been discovered by other groups. So it is important that you click on it because if you don't click on it and you start blinking this image, you will fall into the temptation of resubmitting what other people have discovered before. So by clicking on it, you will see you will see an object that has been discovered with their designation number. So it is important that you click on it all the time so that you don't work hard and maybe you become so unfortunate that what you have reported has been discovered by someone else. So you just have to click on it and to just take some time, and afterwards you will see something will appear on your screen.
I have a question here. Hello.
Hello?
Uh, I wanted to know. I've clicked the known object overlay. Should I
Uh-huh.
click it twice again?
No, don't click it
Second
twice.
time.
Don't click it the second time. No. But if you click it the second time, there's no problem. But don't click it the second time. But after loading, after this thing has finished loading, did you see some red labels on your screen?
Yes. I'm currently seeing some red labels.
Okay. Just hold on there so that my own can finish and also can others can follow suit.
All right.
Meanwhile, please, I'm so sorry. I forgot something here. Your background, the background of your data. Is it black or white like mine? If yours is dark, change it to white by clicking on here where my mouse is, because it is better and advisable to change to white background. So please click on that button there, please. I forgot to mention it. So click on that button there. So
Okay. Done.
okay. All right. So I have these two. I have these two objects here. So these are asteroids with their designation number that have been discovered by other teams from other parts of the world. So you see, if you do not click on this and you start searching for asteroid, you might fall into the temptation of renumbering them again and submitting. So that's a big error for you. So after clicking on it, whatever we are going to find now becomes our own. You can lay claim on it. Okay, you can lay claim on it. So let me now go ahead to blink the images. So I go to blink current. Somebody came in. Excuse me. Okay, no one came in.
Um, just wanted one. Just wanted to ask regards the images, the background.
Yes,
Uh,
it is simulating all the four images. If you check very well, this is image one. Okay, this is image four, image one, image two, image three, image four. So it is simulating the four images and giving you a sense of motion. If you observe very well, look at it here. And you can also observe there are grid lines. You can count them: one, two, three, 4, 5, 6, 7, 8. So if you count it, there are about 16. 4 times 4. 4 times 4. 16. So you are going to zoom twice. You're going to zoom twice to be
so
able.
sorry. Before that, how did what did you press for the image to be in motion? Because
Okay, I
I'm
said
still
blink. Look at where my mouse is. Blink current images. You see my mouse?
okay.
Yes.
Yeah.
Yeah, blink current images.
Okay. That is good.
So you will have these grid lines. I want everybody to be at this stage before I move on. I want everyone, because this is the major part of the exercise. So if you are not following, please just let me know. If you're not following, just let me know.
Rachel.
So is everyone following? Like only one person is responding. No, I want everyone to respond. Hello, everyone. Oh,
Hello. Yeah.
Sigrid. Miss Sigrid, are you there? I want everybody to respond
Can you
to me.
guys hear me?
Yes, I can hear you.
Yes, we can hear you.
Okay. Now I've been here for the past 30 minutes, probably been going in and out. Yeah, I just forgot that I was using my Linux PC, but I managed to get into a Windows PC.
Okay.
I'm just navigating myself. It's installed and everything, so I'm just trying to open up the file. Yeah.
All right. All right. So how about Helen? Oh, Helen just left. Okay, Helen is there. Helen, can you hear me?
Hmm? Yeah?
Are you following?
Yeah, I can hear you.
Yes,
Yeah, I'm
great.
following perfectly. I'm at the same stage as you are.
Okay. So how about Imputa?
This infinite window is funny.
How about Imputa and Julius? Okay, let me just go ahead and move on. So, so now zoom 2 times. Look at the zoom button there. Zoom in. We have zoom in and zoom out. So zoom 2 times. But before you do that, just watch. I want to let you know how we're going to do this. We're going to start from here, and we will search all this grid, and we move on to this side. So we're going to move like this. We're going to move like this. We search everything here. Then we're going to come down. Okay. Then we search like this. Okay. Then we move down again. We search this row. You understand? Then we now move down like this. We finish up. That's the ideal way of searching. You don't just search randomly, because if you search randomly, you just get time unnecessarily, because you're going to have lots of data to analyze. So you just have to develop tactics. And also, this is the first row. I will tell someone that I found an object in the second row under third column. So you should be able to identify with this tactic. So now let me zoom in. I'm going to zoom in 2 times. One, and so then I'll take. Let me bring this up. I will take these to the extreme. I'll take this up. So I am in the first row under the first column. So you search for anything that is moving. Okay? You search for moving objects. Whatever that is moving should be an asteroid. So if you look very carefully, everything is static. So nothing is moving. Nothing is moving. So search for any moving object there. This is the grid. I'll go to the next grid. You search. So you should find some saw before like this. From the Isaac website like this. It is very clear. Very, very clear. Okay? You see these static things, then you see this one moving. So forget about the fact that this one has been discovered by someone and it has been labeled. So, but this is how you see something that is moving. Okay, nothing. So I move to the next grid. I move to the next grid. Okay. Nothing is moving here. So I move down. Okay. This asteroid is disconnected. This designation name is disconnected from the asteroid. It's just a technical error. It's a technical error, but apart from that, nothing else is moving here. Then you move to the next one, to the last grid in the first row. So nothing is moving. You have to check very well. Sometimes you have these faint objects, and you wouldn't know that it is an asteroid or something. Oh, sorry. So I'm done searching for the first row. I've searched all the grids in the first row. Then I'll go down. Like I said before, I want to go down till the second row. I want to start from the second row. So you search. Did you see anything moving? Oh, look at this. Look at that. Something is moving. Have you found it in your own? I found an unknown moving object. I found an unknown moving object. Please confirm if you have found that. Oh, so has anyone found what I've found here? Have you found it?
So my PC was acting up a little bit. Uh, Under which are we in?
Okay, I found this. This is under second row, fourth column. The first
Okay.
grid line. Second row, fourth column.
Okay.
So I want to know if I should move on at this juncture. Should I move on?
But
Analyze another object. The same file. We opened the first file. The first. Let me just show
the
you.
XY25
Let me check.
P10.
Let me check. Let me check. This is the one we
Okay.
opened. This is the one we opened. This one I just highlighted. We unzipped that one.
I can't. Oh, I don't know how to. I didn't change my screen settings, so I can barely see. Okay, you open up.
The first
Oh,
one.
the practice image set.
Yes. You have to unzip it.
Practice image.
You have to unzip
Yeah,
this
yeah, it's
one.
unzipped.
If you unzip this
No,
one,
it's unzipped.
then
Okay.
you go you go inside
Yeah,
and you
yeah.
see this 5. Then open this one. Open this one.
Sorry, I didn't check you anymore because I had to close my screen. Okay.
Okay.
Okay. Because I was on X1, but it's okay. Let me just open up the one that I should be opening up. Backward.
Just do that so that we can move on.
How come I don't have it on here. Okay, no, you can move on. I'll just
Okay.
work on this X5 one. Yeah, XY25.
Okay.
Oh, I can open up another screen.
All right. So I want to number that object right now. I want to number it. So to begin, you have to stop blinking. So how do you stop blinking? If you come to this button here, look at the button I'm pointing to. So this is stop blinking. So that you can number, you come to start blinking. It starts blinking. So, but before you start blinking, make sure your eye is on that object so that you don't point at the wrong object. Make sure you know the object that you want to identify. So, okay, I've seen it. Stop blinking. So this is the object here. Okay, this is the object. So I want to number this object. I want to number it.
Are you sharing your screen? Because I can't see your screen.
Yeah, my mom should confirm if my screen is visible.
We are just seeing your profile
Wow.
picture here.
Can you see my screen now?
No, I can see the screen.
I
Okay.
can see your screen.
And you're seeing
Really?
everything that I'm doing.
Yes.
Yes, I'm seeing everything you can.
Oh, okay. Okay, good. So I have stopped blinking, and this is the object that I have identified. You begin to number it. You have to start from the first image frame. This is the third one, image 3 for me. So let me use this button to drive it to the first image frame. So I can either go backward or forward. This is single step forward. This is single step backward. So you can click you back to the first. And this is that object. Remember, if you can move back, move forward, move back. So this is the object. This is the object here. So bring your mouse to that object and left click. Bring your mouse to that object and left click. So you have this. So do that so that I can move on. Do that so that we can move on. So have you done that?
Yeah.
Okay. So now, before you start numbering that object, there are rules, or should I say there are guidelines, about 4 or 3 of them. First of all is that if you observe this, if you see this is like a Gaussian graph. You see this white dot surrounding this red line, okay? And look at this one also. You have this uh, red line surrounded by these white dots. Now, for a true signal, what we call a true signal, if this object is a true signal, these white dots are supposed to surround it tightly. They're supposed to surround it tightly, okay? And also for this, supposed to surround it tightly. That's the first. So, but for this case, you can see that it is manageable. Okay, it is manageable. So we can just accept it. So that is the first rule. Then the second is come to this point that is SNR, which is 5.9 for me. Ratio. It means signal to noise ratio. Mine is 5.9. What is yours?
I have the 5.9 as well.
Okay. So please, I want other people to tell me what they have. I want to hear from others.
I was not able to actually capture the image since my program stopped blinking. I never seen.
And you didn't identify that object anymore.
No, after that, I tried to click continue to start blinking, but it does not. Uh, I don't know. Probably the system quite failing.
Okay,
Yeah.
I think I can understand your problem. So just come to use this button here, start blinking again, so that you can identify the object before you stop it again. From here,
Okay.
click
I see. I see the button.
down and identify that object, and you stop blinking again. So let your eye be on the object. Let your eye be on the
The moment
object.
I click start blinking, for me, I don't quite see. It's not in motion. Nothing is in motion.
Okay, do you know what? Maybe you should share your screen so that I can see your problem. Let me let me
Okay.
stop sharing so that you can. I want to see the problem that you are facing. So share your screen now so that I can see the problem that you're facing.
Just a moment. Share. Okay. Can uh, can you see my screen?
Yes, I can see your screen.
Okay. So here, can you
Oh, I think I lost connection.
still see my?
The it is breaking. Oh,
Where I'm encountering the problem. So when I click on start blinking, still nothing happens, but I'm able to move.
wait. Okay, do it again. Do it again. I can see your screen right now.
Okay, I click on start blinking, still nothing happens.
I don't know what's going on.
Yeah, so that's a problem I encountered.
Okay, do you know what? Close this and open it up again. Too fast. Just
The,
so
the whole thing.
maybe close the window, the astrometrical window, and repeat all the processes that we've just learned now. You'll be faster. I can wait for you.
Uh, so should I stop sharing
Okay, you can
while I
stop.
do?
You can stop sharing so that I will continue.
Okay, all right.
But is there anyone else that is facing the same issue here? Anyone else showing facing the same issue? Or are we on the same page? Hello? Hello, Sigrid. Hello, Helen. Hello, Nkuta.
I'm like I don't have that problem.
Okay, we are on the same page.
Yeah, we're on the same page.
Oh, great.
Sorry, I'm still catching up. That's why.
Okay.
Because I did XY 25 first. But I see in XY 25 that it's basically just a dark frame that I'm seeing so much.
Okay. Okay, that's the second rule. The second, okay, I haven't actually said anything about this. This is the signal to noise ratio.
Next question.
So mine is 5.9. According to the rule for true signals, the signal to noise ratio should be above 5. Okay? Should be above 5.
And you said yours is 9.5, or
I
how
said,
much did you
sorry, I
say
said
yours is?
5.9, not 9.5.
Oh,
5.9.
5.5. Okay.
So it is signal. So that's
Okay, so then that means
that's
it
the
shows
second.
an asteroid.
Uh at least a potential asteroid. We call it true signals. We don't call it asteroids for now. So,
No, I'm saying the fact that it's showing that signal, then it's showing that is an asteroid, right?
or potential asteroids, yes.
A potential
Because
asteroid. Okay.
there could be many things moving in the sky.
Yeah.
So, the third is this magnitude. This is the magnitude of the asteroid. R. Mine is 20.9. So, what is yours? What is yours?
I have the same. I also have 20.9.
Okay, great. So later on, we are going to perform a little calculation. We're going to perform a little calculation with this magnitude. And
What about the others? Are they also getting the same?
you may not get exactly as mine. You may not
Yeah,
get
but are
exact
they getting
numbers.
any closer? Are they getting any numbers that they actually picking up with to see the signal to noise ratio?
Okay, do we have anyone that got a different number here? I think Helen says she got 5.6, uh 5 point whatever, or even 6 or 7 or point 6 or 7 or 8 or 9 point something. It is still okay. So far it is above 5. You can accept that this is our third rule is this. Like I said, we're going to perform a little calculation when we've finished numbering this object here. So let us go ahead and number it. Since we have seen that this is manageable and also the signal to noise ratio is manageable. So, but how about a case whereby this is below 5? Or maybe these lines, these dots are scattered. And it is obvious to you that this object is moving. Will you reject it or will you accept it? Let me ask. Do you get my question?
No?
And these red lines are scattered around it,
Mm-hmm.
and this signal to noise ratio is below 5. Are you going to accept it or reject it?
Reject it.
Okay, now that is the greatest mistake that most people do. You know, we have had many people that have been participating in the asteroid search for many, many years, and they will tell you that for the past 5 years, they have been the Pan African team. We have discovered, we started the Pan African team. We have discovered, we started this program around um, December around December 2020. Okay, but from that 2020 till now, we have discovered up to 20 asteroids. Just within 3 years, we discovered up to 20, whereas some persons discovered anything and they just get discouraged and stop searching. They reject this thing. So for us, we don't reject. I don't advise you to reject. Okay? So for this object, it is obvious to you that this object is moving. Just accept it, whatever the signal to noise ratio is for true signals. Sometimes maybe it could be 4.8, it could be 4.5. Still accept it.
Okay.
So for that object, like all of us saw that this object was moving. So this shouldn't be a hindrance. So just accept it. So let us go
So
ahead.
anything between 3.5 and maybe 6.5?
Uh, between 3.5 to 6. No, it can be above any number above 5. Any number above 5.
Okay, great.
Yeah, but not too much really.
Can we
Yes.
maybe make a minimum of maybe 3.5 to above, to infinity?
Okay. Said if this object is moving and maybe the signal to noise ratio is not adding up to what it should be, just accept it, even if it is.
Okay.
So let us number it. So to number it, you come here and to before you
Yes.
start numbering, you have to start from the first image. You don't just start from the second or third. You have to start from the first image to number. Then you number the first, the second, the third, and the fourth. So that is how you
That's
number
if
it.
you get a moving image or objects, right?
Yes, if you spot a
Okay.
moving object, you stop blinking, then you start from the first image to number it. Okay? So don't click on anything there. Just come here and click OK. Come there and click OK, and you will see this number that we occupy. The rule states that you have to choose 3 letters, capital letters, and 4 numbers. So choose any 3 letters of your choice and 4 numbers. So I usually advise my team members to, you know, to agree upon the letters we're going to use. So for my Nigerian team, I will say Team Nigeria. So I say T in capital letters, T and G for Team Nigeria. So maybe for your team, you can decide to choose University of Namibia team. You can say University U, University of Namibia team. Okay, or you can say uh, you can just agree upon what to use, and you have to be consistent with it. So, what do you say?
Yeah, we can say, yeah, UNA.
Okay, three,
I it,
three letters. U
Okay, UNA.
N A. Okay, U N A. All right. Then 4 numbers. 4 numbers of your choice. You can any number of your choice. So for Nigeria, I'd advise them to use 0001. So for the first object, so if you discover another object, you can have 0002. You can have 0003. So for the third object, so let us go with that convention 0001. So we have UNA 0001. So after numbering it, you click on accept, and you will see that that number will appear there for that first image. Okay. Then you go over to the second image frame, move single step forward. You go to the second image, and remember you have to keep an eye on it because you shouldn't make mistake of clicking on a wrong object. So if you are confused about it, you can just click backward and click forward again to see that particular object. So this is it. So I will just click here. So this is the object here, and look at the graph. Look at the graph here. It's manageable, okay? And look at the signal to noise ratio for me. Mine is 4.8. How about yours?
Except
How about yours?
this is so slow.
A moment, please. Let me give someone something.
I actually
Angie, Angie, are you there?
Okay, back to work. I was helping someone on the WhatsApp, so sorry for the delay. So, so what do you think we should name this one? We should number this?
know 0002. This
No! Remember, this is the same object appearing in 4 frames. So it will appear the same number. So we use U
ah
and A. Yes, it is some object. It is when we continue searching noise ratio. So accept. So we third frame, third frame, that means image 3 frame. All right. This one is 7.8 signal ratio. So number it.
absolutely something wrong here.
A moment, please. Let me check.
Angie, hello?
Hello?
Yes.
Oh, yeah. Angie, just could you please send me a text offline?
Okay.
All right. So I want to number this one. So UNA 0001. Accept. Then the last frame. The last.
Because it's all in the same slide or the same
Yes.
thing.
Yes. Oh, right.
So what's the difference? What's the difference? So flat field and flat frame. Flat field and flat frame.
We don't need those buttons now. Those are for
Okay.
other operations that we perform on the data. But for now, we don't need it. So I have finished numbering mine on the same page with me. I have finished numbering the object. So after doing that, I will resume blinking, which is this. Resume blinking and observe mine. Observe mine. You see, that object is appearing in 4 frames, having the same ID. Okay? So we have numbered this. We have numbered this. Now, come to this MPC report button. Click on it. You will see the details of what you just did now. The details, you have UNA, this one. Look at that. This is the telescope details. And this is the time you analyze this image. Look at how it looks like. Now this is the magnitude, sorry, the current magnitude of the asteroid that I told you to keep your eye on it. So, and I said you're going to perform a little calculation there. So the calculation is identify from the values you have in your system, identify the highest and the lowest, and find their range. Identify the highest and the lowest. So for my own, the highest is 21.2 and the lowest is 20.7. So the difference. So calculate the difference. If the difference is less than 1, it shows that the object is a true signal. Do you understand?
If it was what?
What? Didn't get that part well.
What did you get?
No, we didn't hear what you said. If the difference or is it?
If the difference is less than 1, it shows that it is a true signal. But if it is more than 1, it is a false signal. So check for your own to confirm what you got as a difference. What did you get?
1.1.
1.1? Wow. How about, how come you got 1.1?
You said you take the highest,
Yes.
maximum, minimum.
Then minimum. So who else got more than one? Please, I want to hear. Someone is chatting on the group and I want to respond to that person. Just a moment. Mine is 0.5. 0.5. So, but whatever. Maybe for some reasons our data may be different. I don't know. But we should be having something very close.
Getting him, or you guys are lost?
Oh, no. Uh, for me, I understand just that my internet is slow plus the PC, so you guys are way ahead because I had to restart.
Working, so I couldn't identify the object again. mm, Besides the first image, so now I'm just following along what you're doing without doing it myself.
Hello, Juliet. Can you speak now?
Me?
Hello, Julius. I think Juliet
Julius.
is not able to is not able to speak. Maybe you should
Oh,
unmute yourself. Unmute yourself.
Rachel. Rachel, are you able to unmute yourself?
I think her connection will be bad.
Wow. Or maybe you should go and come in again. Maybe it's a technical error. She can hear me,
No, we
but
just,
no one can hear her. I can't even see her microphone.
oh, maybe she had blocked herself from that from the beginning.
Yeah, maybe she made a mistake and maybe she didn't know how to unblock herself.
I believe it's all our first time using this.
Okay, that day I
Yeah.
told you that Google Meet works smoothly without those hanging stuff. But that day we used Zoom. I was experiencing break, some break, so that's why I said let's use Google Meet. But maybe next time we should. After the meeting, we'll go through the video again so that you can understand it.
Yeah,
Because it's I'm streaming it live on YouTube and I'll send the link
okay,
afterwards.
good.
So after seeing this, you can just cancel it. Cancel, and you resume searching. You have to continue searching. Let's go down. Let's go down to check for other moving objects because after identifying one, you don't have to stop. You have to.
Saying that within we're looking at, or the data, the file that's open, right? Maybe in 3 frames or something like that.
Okay. We have it in 3 or even 2 frames. For instance, into this grid line and you won't see it again. So you might see it again. So you might see it in
Yeah.
2 or 3 frames. Do you understand? So in that case, you accept it in the frames
Mm-hmm.
you spotted it. Okay?
Uh,
So, but in this case, it appeared in the 4 frames. But we have such situation whereby you have it appearing in 3 frames and maybe it will disappear in the appear in the first or in the second and disappear in the third and reappear again in the fourth. Or first, disappear in the second, appear again in the third, and again in the fourth. So you can have different combinations but you should have it in at least 2 frames to confirm that this object is moving. And moving objects are so easy to identify, they're not hidden. So I have to continue searching. Okay, so I'll move to the left. check. Nothing is moving here. Go up. Nothing is moving. So you move to the next grid line, to the next grid. If you observe, this is describe it. During the time these images were taken, it was an error. So you should keep our search and oh, I saw another object there. In fact, I'm seeing two objects. I'm seeing this and I'm seeing this. Can you see it in your own screen? Can you see it in your own screen? Can you see it in your own screen? I saw two moving objects. There. Have you
Yeah,
spotted
it's
it?
sort of
Okay.
appear, yes.
Oh, great. So I have found two moving objects and they have one. So let us number it. You have to stop blinking first of all. Yeah. Then you go back to the first frame. You go back to the first frame. And while doing that, you have to keep an eye. Look at the graph. Look at the signal to noise ratio. It's about only 7. So without wasting time, just number it. So I want to know how many persons that are following me. Let me check on.
Yes. We sort of follow. I'm sort of following, but my loading is taking.
No problem. I'll be patient to wait for you.
Similar here as well. Just at the moment
But I hope you're
waiting and doing.
practicing along, like you're practicing along with us, or you're just looking at the screen.
I'm no at the moment I can't practice. My PC is acting up a little bit.
So I'll click OK. Then you delete this UNA UNA. So what do you suggest? 0002 because this is a different object. UNA 0002. Accept. You go to the next frame.
Okay.
All right, this is for the second frame. Accept. Then the third frame. So I'll delete this UNA 0002. Accept. So we have UNA 0002. Accept. So I'm done numbering this one. Let me go. Let me start blinking so that I can identify the other object that I spotted here. So this is the object. Let me bring this down, scroll down. So this one is so I have to stop blinking again. First, oh, look at this one. This one looks so perfect. This is exactly what we're talking about. It looks so perfect. You see how those dotted lines have just wrapped around this red line, and also this one, and also look at the signal to noise ratio 16.8. All right, so I have UNA 0003 because this is the third image. Then I'll move to the next frame. I look at the graph, look at its SNR value. Looks so perfect. I have UN. All right. U03. Accept. Then we have the last frame is
Yeah.
question. Okay, ask your question.
So this moving object, it moves through all four frames or nearly 2 to 3.
Yes, you can move in 4 frames. But for the case of 2 or 3 frames, sometimes when they are moving, they disappear into those grid lines. So in that case, you have to just accept it for the ones you saw the object. We're going to see we're going to see an example very soon.
Okay.
So I have finished numbering my object. Look at them. So I can resume blinking. So these are my two objects that I have numbered. So, and let us look at our MPC report to see how it looks. Look at it. So we have more objects here. This is 00. This is for the first one we identified. This is the second one. This is the third one. So you can go ahead to calculate your SNR value. But I've told you just accept anything that is moving. Then you can cancel it and continue searching. Continue searching. So I have to come
Oh,
down.
another question here.
Okay, ask your question.
So at the calculation part, if the difference is more than one, then I should delete that.
No, don't delete it. Just accept it. Have to know them in case if you want to teach other people. Okay, so we can just truncate those rules for now. But after this tutorial, you can just read the manual so that you can understand it much better. The manual guide, and you can understand it in more details.
The ID is where?
It's there. Let me show
Is it
you.
on the web?
It's there in the Isaac website. Look at it here. This one. This is the astrometrical guide where you downloaded these two files.
Oh,
This one here.
okay.
So you can download it and read through it. About 4 documents there. So after this training, you should go through it and it will just make sense to you because everything I've just told you here was also explained there.
Okay, okay.
All right. Keep moving up and down, up and down. Nothing is moving. Oh, look at this one. The third, sorry. This is in the third row and third column. Third row, third column. Look at what I'm seeing there. And if you observe, it seems like this object disappears in the first image and appears in the other 3. Blinking and understand it very well. Stop blinking. It's clear. It is not clear in the first image, in the first frame.
Mm.
But if you move, so we are going to just number it based on where we from the
From
second.
the second seems
Yeah,
to be attached to the star there.
yeah. You have to be very careful so that you don't number that star. So just carefully point to it and see it. I have done it. I have carefully pointed to it. I didn't make that mistake of pointing to that star.
So in a case where you point to a star by mistake, uh, what would the
Oh, you
the
shouldn't
the, the,
you
the
shouldn't make such a
classification be?
mistake. This is actually part of science, so you have to be very meticulous to number the right object. Okay, you're
Okay,
asking
but
what if it overlaps
since
that star?
since that since that okay, fine, those stars are very close, and you happen to click actually, and then what happens?
Okay, how do you know that it's a mistake? Maybe you discover it's a mistake. Is that what you mean? Maybe it's a mistake.
Yes, like you just instead of clicking the moving star or the moving object that you sorry, come a star, moving object that you saw, you clicked on the
On the
object that
stars.
had been stationary. Yes.
If any form of mistake that you have done during the process of
Mm,
analyzing your image and you have
mm.
discovered it and you want to correct it, you have to redo that object again. You have to redo that image set again. To
So basically, here you just reject.
don't reject. I got it right for mine.
Yeah, yeah, because you got it right. But in my case now, if I had the red circle on the reject
Okay,
this
yes,
and start
just say reject. Yes, if you say reject, you can
Mm-hmm.
you can point to it again. You have to be very careful. So you can reject it, reject. You can just, or can even.
I actually wanted you to. I actually
Actually,
wanted you to click on the.
star, you still get the same data you're getting here for a moving object like the SNR in all those. Is it quite the same?
Okay, let me click
Let's
on
see.
this. Let me check this. This is a star. Look at what I
Mm-hmm.
have. Well, this is
Mm-hmm.
about the magnitude, okay? Um,
Mm-hmm.
this is called apparent magnitude, distances away in the sky, but they may have the same magnitude. Do you understand? So it's just a coincidence. So you can have a big star that is very, very bright, I mean, in terms of the absolute magnitude, but because of the magnitude will be the same as an object that is close by, maybe a planet. Do you understand? So in that case, it is if they are the same or if the same apparent magnitude, it's good. I hope you understand my point. Signal to noise ratio. So I have never seen an
Mm-hmm.
asteroid have such number of signal to noise ratio, and there is also uh,
So were you? Mm-hmm.
another rule that says that stars like because they give you this kind of saturation. So kind of a saturation. So you shouldn't accept those ones. Please go for the ones that
Um,
are.
Saturation, as in the term of the fit line for the Gaussian law, is basically in order, or like have it's showing a best fit, or what are you referring to?
Repeat your
Or
question.
saturated? No, I'm saying you say that they're called ample magnitude, and on top of that, you say they saturated.
Okay, why observing? Why them so much? They are going to saturate the pixels, and it's gonna give you this kind of spike. These spike things.
So
So they can
yeah, so now
saturate.
I
They
want
can
to
saturate
understand.
your 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 images really quick. So you shouldn't just like you just immediately um you are facing a light source and immediately you switch it on. You know how it feels when you look at it when your eyes are open, so it will just immediately saturate your eyes. So that's the same idea. So these stars, they can actually saturate your data, the data that you are collecting.
The
Saturation.
Objects, they can or can't.
No, they can't give
Oh,
you.
they can't. Okay.
Yeah, they can't give you saturation. They are very tiny. You need a specialized telescope if to observe these things. When you discover
Yeah,
asteroids, you can also view them on stellarium. I've done of our discoveries when we discover these asteroids and they get cataloged in the minor planet center. So you can use stellarium to know where they are in the sky, even right now. So
Oh, nice.
yeah, you can. I have done that for our Ugandan team. I've done that. You can just know where, once your telescope is connected to your computer, asteroids. These asteroids are magnitude is just about 20. You can have them from that 18 to 22. So they are
Oh,
quite faint. For the human
not
eye, the brightest object you can see is around that 4 point something. I can't remember exactly. The magnitude is about 4 point something, or I don't maybe 6 point something. So you can imagine you have about 18. This thing is a negative value for bright, like the sun. The sun is so bright. That's the brightest object we have in the sky. It's about minus 22. Then we have the moon, which is about minus 18. Then you keep coming down for these other bright objects in the sky. So when you get to plus 6 point something, um 6 point something, you can continue to see those objects even if you go out now. If you go out 6 point, which is the close to the minimum human eyes can detect. But above 6 points, you can't see it. Even if it is there, you can't see it because you can even use it with your light bulbs. You can just ask the question, the light bulbs in my room in the sun, which is brighter, and maybe you can even try to calculate the apparent magnitude, or maybe try to compare the light bulb in your room with the stars you see outside, and you can just start getting the feeling of what apparent magnitude is. So then we have another one called absolute magnitude. That one is for how that object will be if you are observing from a particular distance or anything in the heavens. If you bring them at 10 mega per sec, something like that, how bright will they appear? So we call that absolute magnitude. So that's by the way. But for here, this is just the magnitude, how that object will be. So, like you asked me before, can the object appear in two frames or 3 frames or 4 frames? So this is a typical example of such. So for this one, we have it appearing in 3 frames. Frame it just disappears in the grid line. Sometimes you can have it like this. I have seen such case. Maybe you have it here, then you have it here, then it will disappear here.
Good.
You understand? So in
Oh,
that one,
yes.
you can't account for it. So you only pick for those ones that you can see. So like today,
Okay.
I want us to be working on two of those images that we download. Then later on, you can practice with the other three so that. So let's
But
number this. Okay, ask your question.
here, it appears to be slightly outside touching the grid line. So if you
Yes.
happen to click on that,
You
will
no
it still give?
can give you 3 frames or 2 frames. It is enough evidence that this is an object. This is a moving object. Okay. Even if I
Right.
refuse to, maybe if I number it in the first and the second and third, and I refuse to number it in the fourth, it is those ones have numbered are enough evidence to show that this is a moving object.
Okay.
So let's go and let me stop blinking to number this. Okay, stop blinking. Stop blinking, then move to this one. So
So this the white dots that surround the red line, that just indicates what exactly?
this is just the background. It's supposed to be the dark sky. You changed it.
No, no, no,
When you clicked on
no.
that
Here
bit.
on the graph with the red line. Yeah, that one. So the white dots,
Okay,
the
you're
closer
asking.
they are to and accumulated to
Yes,
the red
the more
line,
accurate.
this really signifies.
Yeah, the more accurate the object, the closer they are, closely aligned to that line, the better. 0004, 0004, UNA 0004. Accept. Then move to the next one. Okay. UNA 0004. You know, a team can work in a particular image. Yes, it's possible. So maybe if they are in the same place, they can work, or maybe if they will discuss their search and where they found something. And while submitting it, you have to you have to indicate your names.
This the moving objects that you are recording now. So if I happen to go on, uh,
This is a real data, fresh data from the telescope. And after analyzing it like this, I submit it. Uh, it will undergo several studies. It receive the reports of what you've done. So preliminary discovery. Then it will undergo another level of studies, about 6 months. Then this is an asteroid or not. So it will be given a provisional number. A studies which might take up to 6 to 10 years. So when the International Astronomical Union has fully uh, studied the properties of this asteroid, that is when they will come to you and say, you discover this asteroid, name it. So you can
oh,
choose to give it your personal name or the name of your group members or even the name of your university. You have had people named after an asteroid. In fact, we use it as a reward in the science community. Like the last year's Nobel, no, last 2 years, an astronomer, a very popular astronomer in South Africa. She died last year. She got a designation. So that one, they didn't search for asteroid, but we have some asteroid that need to be numbered, so they were honored by that. But for this one, you worked hard for it. When the time comes, you'll be informed if you really want to be named, want to give it your name or the name of your university. So it's a very wonderful and a rewarding activity.
oh, so there are possibilities that these moving objects are not even asteroids,
There
because they
is,
have to go
there is,
through all these stages, and then after a
there
period of
is.
10 years
Uh,
of study,
Um,
and then
it's not really. They also determine the and the orbit. You know, some of
oh,
like some of these asteroids, they could be moving the final name, and sometimes, just in a rare case, it's very rare. Um, After you must have discovered an object, I was having that conversation with an astronomer. He said that even if you have a provisional discovery, there is also a possibility that someone else has discovered it. But it's very
oh,
rare. It's very rare. So just keep searching so that you can have multiple discoveries. You know, these asteroids are billions. There are billions of them. About 1 million plus have been discovered and cataloged. So we still have many, many of them. There are so many, as many, and the way they move like dust. They move like dust in the solar system between the orbits to the sun. There are so many, like moving like dust there. So there are billions of them. So there is many more to be discovered by citizen scientists. They collect this data, and those experts working in NASA, the numbers are not enough. They don't have the number for scientists to analyze this data. So they depend on the public. And they can't even
oh,
use artificial intelligence either because doing right now.
uh,
They have not advanced to that stage. So that is why they need human input into it.
so now, given the fact that these asteroids are related to that million, and
Oh,
the number of scientists that analyze this
okay, like
asteroids are
for instance,
few.
like this, assuming this is a new day, this one were just spotted. Okay,
Right.
were just spotted. So when you analyze the data and you report it to Isaac, and Isaac will now report it to the Minor Planet Center, they will study it and say, yeah, maybe this is a potential asteroid. They will catalog it so that we can determine where the preliminary orbits. Then further studies will continue. Because one thing about this asteroid is that once you see them with those telescopes, you may not find them again. Videos or pictures of how they are moving in mass, you know, it doesn't really appear that way. I was listening to one astronomer. She was saying that the typical distance between two asteroids in space can be uh, up to one astronomical union. I can imagine billions of asteroids separated by a distance that is like from, and you do not study it immediately, you may not see it again. So that is why they just keep appearing and disappearing. But if you spot one and you catalog it, you can track the trajectory and spot it again for further studies.
No, yeah, but right. What I mean is that in this case, if we record this, let's say for instance, we record this one and then we send them to the Isaac, it will be sort of like on the pending list because of other millions that have been added already before this one. So this
Okay,
data still
this
has to
this particular data is for your team only.
right.
It's for
Yes.
your team only. It is not given to other teams. It is for your team only. So whatever you see here, not for anybody else. No one is analyzing this particular data. Assuming we are in the campaign, this data is unique to your team. So it is not like other teams are working on it.
Oh.
So whatever you see there, uh, is yours, and you're not uh struggling it with other people from other parts of the world. So let's. I think I have numbered all of them. Can look at
Yeah, the
it.
fourth.
Yeah. So you can go on and on to check for the rest of the the column. Sorry, the row. All right, I've done this before. I've been using this to teach other people, and I have discovered that even if you continue searching, you won't find any other thing. You won't find any other thing. So, but you can on your own just keep searching. And so let us come here. This is the MPC report of everything we have searched. And if you look at that fourth, it took numbered it in 3 frames. So that is why it is 3 here. If it appeared in two frames and we numbered it for those 2 frames, you only see 2 information about that data here. So we are done, but don't ever send it to the Minor Planet Center. Look at this is the email of the Minor Planet Center. Some people make that mistake and submit directly to the Minor Planet Center. Please, Isaac strongly warns against this. You don't submit it through this means. We have a means we do that, and I'm going to show you. I'm going to show you an example. Okay.
If-
We have our um, Uganda team. They are searching. I'm going to use their page to show you how you submit. So what you do is you come and copy everything.
uh, but before you copy or you remove that, um, is there ever a case where like for let's say the fourth asteroid we recorded, what if the is it the magnitude
The
the,
magnitude
the
is
yes, What if they're all equal? Is there ever a case where they're all equal? As in
But
when
I have not
you
really
have to get
seen
now.
I have not really seen the case where they are all equal. It's a very rare case. There's gonna always be a fluctuation. But just take
Are you
the
asking for
asking for.
She just left.
Okay, so after analyzing it, you copy. Maybe you don't want to submit it now. Maybe you want to keep analyzing other images and later you can submit all of them. I'm going to copy it to my notepad.
Okay.
Notepad. Don't copy it to your Word. Copy it to Notepad because this thing needs not to be distorted. It needs not to be distorted. Notepad will give you like it doesn't have this word wrap. It has it, but it is the feature is quite large. It can allow you to store Notepad. So let me copy it to my Notepad. So this is it. You see, Notepad has not mutilated it. It has not changed the way it looked like. That is why I
Oh,
say you
okay.
should store it in the Notepad. I want to downloaded it before. This is the one we unzipped. We unzipped this. So let me go to properties. I want to copy the name, the number. I mean the number of this image from here. Copy, cancel. Then because I want to indicate the name. So this is the image. So the next one I'll bring it here and I'll keep storing it here. So let us see. Okay, let me ask, what if after searching for maybe analyzing an image data and you couldn't find anything? You didn't find any object. We have such cases. In fact, such cases are more prevalent. You
Oh,
can during the real campaign, it is very very hard for you to spot a moving object. Very very hard. It's only on rare cases that you see uh
moving
moving
object.
objects. So let us see such case. So in that case, I'm going to be using this because I have actually this third image set. It can give us
Okay.
such case. So I want you to unzip it because we are going to be analyzing it. Unzip it so that we can see such case. Unzip extract file. Then go back to your program. You can close. Oh, sorry. You can cancel this, and you can. I'm done analyzing this. Remember, I'm done analyzing it. So I can close all the images. Close all images. Says, do you want to close all images? Yes. I want to close all images. Then you have to also delete this report because I'm about to load a fresh image data. You have to delete the first one so that it does not overwrite this. It wouldn't even overwrite it. It will just keep piling up. Assuming that uh, you discover moving objects in the one that you're about to load now. It will just be piling up with the first one. So what to do is to clean it up before you load a fresh image data. So how you do that is you come to the settings here. Come to the settings. Oh, sorry. not settings, come to a file here, then you see reset files. Reset
Okay.
files, you click on it. Observe what is going to happen right now. This is going to go. So do you really want to reset this and this? Say yes. Observe. So it's gone. So you now have a fresh start. So you can now load the second image. Load the second image. So this is that one we did before. Let me go to my downloads again. Downloads, practice, image set. This is the second one we are on zipped. This is that second one that we unzipped. You open it. You open it. So then you highlight all of them. You load. So it has finished loading. So the next thing, like I told before, you have isometric data reduction. The third image.
The,
The third
or the
image.
third one.
Yes, the third one.
Try.
So when you load the image, you click on. I hope what's her name? I forgot. Is still with us. Let me check if Rachel is still with us. Because she was left out and okay, I think she's still here. Hello Rachel. Unmute yourself. I hope you can hear me. You can follow us at this point because we are about to analyze a second image data.
I think she should be active on WhatsApp, I guess.
I'm trying to communicate with her. I hope she'll respond. So, unlike before, we had this error with that reduction, but now this one went smoothly without those errors. So, this is another typical example that it is not all the time that you experience